Let's look at the effect that charge has on acidity. So atoms that have a positive charge will be more acidic than atoms that are neutral. Let's look at this just using the autohydrolysis of water, or the autoionization of water. So if we have two waters, we can have that break into an H3O plus and an OH minus. And this process happens, but remember the K, or the equilibrium constant for this, is 10 to the minus 14. So not much of this is happening. And if we looked at the delta G for this autoionization, it's plus 80 kilojoules per mole. So it's not a thermodynamically favored process, although it does still happen to a small extent. But this brings up the important point. Generating charges will take energy. There's the same bonding. So there's a hydrogen, it's bound to an oxygen. There's hydrogens bound to oxygens. Same type of bonding. However, because of the charge separation, it takes energy for that to occur. It's much more stable to have no charge. So how could we apply this to looking at acidity? So if we looked at the ammonium ion, which has a pKa of about 9.4, and we add water to that, we can generate the ammonium, or the hydronium ion. So we have ammonium making hydronium. And this is a relatively favored process. And you'll notice that we did not generate any new charges. Up here with water, we took two neutral ions, or molecules, and we generated two ions. That was not very favorable. Here we took a neutral molecule and an ion, and we made a neutral molecule and an ion. So it's very similar on either side. So this will be more favored. Let's look at another process, which we've just taken the ammonia, and we're going to try to do the same thing. Now, I will tell you that this is not a forward favored reaction. So we've generated an ion here, but we're also going to generate another ion, the hydronium ion. We've made two charges from neutral species. So that is much less stable, and that is indicated by the pKa being around 36 for this. Which means that this reaction is very unlikely to occur in the forward direction, because it would be terribly energetically intensive to make happen. The delta G for this would be very, very large, is what I'm saying. And so it would be difficult to do that. All of that is to say that if we have a group that has a positive charge on it and it's protonated, this will be much more acidic than that same group that is uncharged. It's a lot easier to give away an H plus when you're already positively charged than it is to generate an H plus out of a neutral species. So, with that, thank you for joining me, and we'll see you in the next video.